Good evening. Welcome to the graduation ceremony of the Department of Physics and the Engineering Physics major. My name is James Analitas. I'm the chair of Berkeley's Department of Physics. Before we begin, may I ask that everyone please turn off their phone? That goes for you lot too. It has been and is the honor of a lifetime to serve as chair of this wonderful department. The last 3 years have certainly been a test for all of us. But we have achieved a lot together. We created the Pi Squared Undergraduate Fellowship, physics' very own undergraduate research fellowship that rewards not only the fellows for their achievements, but also the mentors, the graduate students and postdocs for their leadership. We created the Physics Innovation Lab, physics' own makerspace that students can learn to create, begin and invent independently. And with one final donation from former Professor Paul Richards' family, we will hope to finish the construction this year, so look out for that. We couldn't have done this without the help of our donors. Now, usually that's a hint to the parents in the room, but I realize that's also the hint to the graduates too. Now, we did many more things, of course. We kicked off our grand plan for infrastructure, now in the hands of Dean Khan. We created a better articulated PhD program, and a set of community principles to emphasize that despite our diverse perspectives, we come together with respect, with understanding, and above all, with empathy. I feel indebted to the undergraduate and graduate students that have worked with us over the years to make this vision a reality. Although I think I'm contractually obligated to now call them graduate student employees. Too soon? What is special about Berkeley Physics is not just the things that we learn in the classroom, it is the community that we've built. And I hope you go away today knowing that you have lifelong friends to support you as you grow in the future. I am delighted to welcome to this Berkeley graduation ceremony the parents, families, and friends of our students who made this all possible. Now students, could you please stand and face the audience? Graduates, please join me in applauding your families and friends in recognition of the love and support provided during your years at Berkeley. Thank you. Please sit. The physics department recognizes that UC Berkeley sits on the territory of Huichin, the ancestral land of Chochenyo-speaking Ohlone people. This land was and continues to be of great importance to the Muwekma Ohlone tribe and other familial descendants of the Verona Band. We, the Berkeley faculty and staff who have worked with these students, are also proud of their accomplishments. We have watched a talented group of young people progress through a challenging curriculum, emerging as confident young innovators and physicists with great promising futures ahead. So now I'd like to introduce the people joining me on stage. I will introduce them one after the other, but please hold your applause until I finish the introductions. First of all, Natalie Wolchover, today's principal speaker, Pulitzer Prize-winning journalist and senior editor of Quanta magazine. Alina Grace Vasquez and Chitran Murdia, graduating students from the physics department, will be our student speakers this afternoon. Professor Stephen Khan is Dean of Mathematical and Physical Sciences in the College of Letters and Science and Professor in the Department of Physics and Astronomy. Professor Dan Kaysen is the Head Graduate Faculty Advisor of Physics, and Professor Holger Mueller is the Acting Head Undergraduate Faculty Advisor for Physics. Why is it just acting? Aren't you actually doing it? Lastly, I especially want to acknowledge the members of our physics staff responsible for organizing today's festive event. Anna Hilke, Gloria Trujillo, Elizabeth Nakayama-Ryan, Joel Miles, Kathleen Cooney, and Isabella Mariano. Thank you for an outstanding job organizing this ceremony. Families, this crew of professionals is the team who advised and encouraged our students and your graduates over the past years. Please join me in thanking the faculty and staff and the important roles they played in the successes that we celebrate today. Now, our graduating students are part of an extraordinary legacy here at Cal. The physical sciences have been an integral part of the campus from the beginning of the University of California 151 years ago. Berkeley, established in 1868 as UC's first campus, has become the world's most distinguished public university, guided by the motto Fiat Lux. The university's purpose is to create knowledge that will both inspire us and improve our lives, to be a beacon of opportunity for each new generation. Now, you students are part of Berkeley history, and you are part of that legacy. Thank you for being part of Berkeley's journey. We are honored to have you as Berkeley alumni. A degree in physics is not for the faint-hearted, and so I know you are all up to the challenges that are ahead of you. You may not know it right now, but you have the tools to help you answer the world's greatest questions, and I have no doubt you will volunteer to be a part of the solution to those questions. Whether in solving nature's greatest puzzles or tackling climate change or energy security, you have a secure spot in answering our society's greatest challenges. My only advice, if I'm allowed to give any, is that you spend some time identifying where you will have the most impact. And that will be different for each one of you. And if you ever have the opportunity to make a difference, I beg that you take it. Take it because those opportunities are surprisingly rare. I hope you take our department's principles with you too, to listen, to learn, and to approach one another with empathy and good faith. It has been a privilege to have you as students within physics. Yes, we've been your teachers and your guides, but you walk the path mastering the most difficult courses and material, becoming physicists. About 1/2 of our graduates are headed for graduate school, while others are headed for careers in education, industry, medicine, and engineering. Many of our new PhDs will be doing postdoctoral research. Others have fallen in love with the Bay Area and will remain to create their own companies, or drive new technologies that have made Silicon Valley the center of American innovation for decades. Our students have the foundations they need to do whatever they deem most important and most interesting. They have become confident problem solvers, deftly able to deal with an increasingly complex world that we live in. They will never stop questioning. They will look at the landscape of challenges before us with new eyes, to paraphrase Marcel Proust. They are not only on a voyage of true discovery, they are on a mission to better the world. Graduates, you should be proud of conquering the rigors of a demanding program. I would say you've crossed the finish line, but actually you've only crossed one milestone of many that are ahead of you. So congratulations. As our newest alumni, you are the university's best envoys. Your future achievements will demonstrate to our state what a treasure it has in the University of California and its crown jewel, Berkeley. It is important that our doors remain open to all young people who can help move our state and our country forward, creating a stronger economy and a more just society. But please stay in touch. Join us on social media, return for our special lectures, volunteer to talk to our students, and bring your families to Cal Day. This great university relies on the success and support of our alumni, who now include you. And now, I am delighted to introduce our undergraduate physics student speaker, Elena Grace Vasquez. During her time at UC Berkeley, Elena has participated in medical physics research at UCSF and Harvard, which focused on the optimization and creation of imaging modalities for disease treatment, as well as participated with the Ginsberg Group on furthering the understanding of the energetic landscapes of complex materials through stroboscopic optical scattering microscopy. As the co-president of the Society of Physics Students and the Diversity and Equity and Inclusion representative in the physics department, Elena has worked to create and maintain an inclusive and welcoming environment for us all, regardless of background. Next year, she will begin her PhD in applied physics at Harvard. Please welcome Elena Grace Vasquez.
Students, academics, great friends and families, sometimes I sincerely cannot believe that our time at Berkeley has come to a close. When I first arrived here, I quickly realized that the sense of purpose, care, and want for change and growth is the common denominator between all of us. And so, with some further reminiscing over my past 4 years, I can say that there have been 3 words that encapsulate my experience. The first word is inspiration. Berkeley has taught us intricate and advanced physics. It has taught us how to participate in and contribute to the advancement of scientific research. It has taught us how to analyze possibly every scenario, even if it does not actually make much sense. It is important to recognize that at the core of all these lessons are incredibly inspirational figures. Time and time again, I find myself being in awe of not only of those in higher positions than me, but also of those that I am surrounded by daily. My peers, those in physics and those in completely different fields, have inspired me to do new things, become a new person, go on new journeys, and have new mentalities. You all constantly inspire me to strive for the next galaxy, to believe in myself, and to be so proud of what we all have accomplished. The next word is persistence. As we all know, our college experiences have been anything but normal. From dealing with an ongoing pandemic to participating in or being in solidarity with strikes for better wages, we have all managed to pull through in the most beautiful ways possible. From helping each other on problem sets until the late hours of night, to using our voices to preach for what we believe in, day by day, we continue to persist for changes that will positively impact all of us. We continue to do our best to learn as much as we can, and we continue to inspire others. This persistence does not go unnoticed, and it is something that is in all of us and is so incredibly special. The final word is gratitude. With my time in Berkeley Physics now being at its end, I have realized that this is all so much bigger than myself. Along this journey, there have been so many amazing people that touched my heart and who changed my life. I am grateful for the moments of solidarity between many of us on how hard it is to get through physics at Berkeley. This vulnerability is so important, and it allows for people to realize that they are not alone in feeling this way. I am grateful for the dedication of many to continually foster and further a safe and inclusive environment. This is integral to genuine learning and reminds everyone that they belong here, regardless of their chosen identity. I am grateful for the ability to learn from, to chat to, and to work with the most incredible minds in our field. This has allowed me to continually push myself out of my comfort zone and help me realize that even if sometimes I don't feel like it, I actually do belong in physics. I am grateful every day for my friends and for my family. Everything that we have gone through has continually made us stronger and has shown me what true unconditional love and support are. I certainly would not have made it here without you all. Moreover, I certainly am so grateful for my incredible mom and am so proud to acknowledge all of the beautiful mothers out there. Although we are celebrating us graduates right now, this day is also for you. Happy Mother's Day. To conclude, it has become clear that Berkeley has taught us life-changing things. You name anything, and we all have likely learned something about it by being here. But most importantly, Berkeley has instilled in us that we can and will make a difference in whatever way we see fit. Thus, I challenge all of us to make a difference in not only the technicalities of what we choose to pursue next, but to make a difference in the lives of the people around us. The people we know best and love, the people we don't know at all, and everyone in between, because being an inspiration, providing someone with those little extra doses of persistence, or showing gratitude can change someone's life. And I know that if there's anyone who is perfect for doing just that, it is a Berkeley graduate. Thank you all so much for this honor, and congratulations, Berkeley Physics Class of 2023.
Thank you, Elena, and best of luck to you. I'm delighted to introduce our graduate physics student speaker, Chittarang Murdia. Chittarang grew up in Udaipur, India. He did his undergraduate at MIT, where he double majored in physics and math. Chittarang works on quantum gravity and string theory, and has been particularly interested in the duality between gravitational and non-gravitational quantum theories. He's also been actively involved in teaching and mentoring as a graduate student, and has been awarded the Outstanding GSI Award and the Teaching Effectiveness Award in this capacity. After graduating, he will continue his academic career as a postdoc at UPenn. Please welcome Chittarang Murdia.
Thank you, Professor Enlitas, for the kind introduction. It is an incredible honor to be standing before you all today as the graduate student speaker. As I gaze at this crowd today, I am in a superposition state of emotions. I feel a sense of pride for all our achievements, deep gratitude to everyone who made this day possible, and a touch of sadness as we bid farewell to Berkeley. As we celebrate today, I want to recognize and thank the people who have played a role in our journeys. First and foremost, I want to thank the faculty advisors, co-advisors, postdocs, collaborators, and the faculty at large. Your dedication to teaching and mentoring us has been invaluable. Your encouragement and feedback have been instrumental in shaping our research, and you have taught us a grand ensemble of skills that we will carry with us throughout our careers. Thank you to our graduate student advisor, Joelle Miles, for all the logistical and emotional support she has provided at every step of the process, from sending us the admission letters to making sure that Cal Central is ready to let us graduate. I thank Professor Mueller for helping us navigate through the process of becoming researchers. I thank Professor Shapiro, Professor Hedeman, Christian Natividad, and Donna Sakima for guiding and supporting us to become better teachers. And I also thank Professor Enlitas, Roya Ferrazares, and also the union membership for helping us build this vibrant and strongly interacting Berkeley physics community. To our families, our parents, grandparents, siblings, spouses, partners, and also our friends, thank you for being our constant support system. Your love and encouragement and belief in us have been our pillars of strength throughout this challenging journey. You have been our sounding board when we needed to vent, and our cheerleaders when we needed to celebrate. Your unwavering support has been the driving force behind our success, and we hope to continue to make you proud in all our future endeavors. I will miss so many things about Berkeley. When preparing for this speech, I asked fellow graduates what they would miss the most after they leave Berkeley. People said the food, the weather, the hikes, Berkeley Bowl, but the most common response was the Cal community. It was this incredible community that made our experience here so special. Honestly, without the support of the fantastic people I've met during my PhD, I am not sure I would have tunneled through the seemingly infinite potential barrier. From discussing physics over a drink at social hour to impromptu cafe runs when I needed a break, I am truly grateful for each and every person's world line that has crossed paths with mine. Fellow graduates, we made it. We have all worked incredibly hard to get to this point. We've endured early morning lectures, countless all-nighters, endless calculations, and ceaseless experiments. We devised ways to do research during lockdowns, woke up at odd hours to attend Zoom talks, and supported each other through months of isolation. We have tackled difficult problems and overcome setbacks, and we should be proud of ourselves for our perseverance and dedication. As we go our separate ways, let us remember the bonds we formed during our time. Let us cherish the friendships that we've made and continue supporting each other. In conclusion, I would like to thank everyone who has made this day possible, especially the organizers, Anna Hilke, Elizabeth Nakahama Ryan, and Claudia Trujillo, and also the commencement volunteers. This is a momentous occasion, and I feel incredibly grateful to have shared it with you all. Congratulations to the class of 2023. Go Bears!
Thank you, Chitrang, and best of luck to you too. I am delighted to introduce today's commencement speaker, Natalie Walchova. Natalie is a senior editor at Quanta Magazine, covering the physical sciences. Her writing has won numerous awards, including the 2022 Pulitzer Prize in Explanatory Reporting, and has been featured in the Best American Magazine Writing, the Best American Science and Nature Writing, and the Best Writing on Mathematics. Now, I should point out, we invited Natalie before she was the Pulitzer Prize winner. So I kind of feel we got here first. She was Cornell University's Distinguished Visiting Journalist for Spring 2022, a Director's Visitor at IAS in 2017, and a writer in residence at the Kavli Institute for Theoretical Physics in 2016. Walchova studied physics at Tufts University and briefly at the University of California here at Berkeley. She is currently working on a book about the search for the unified theory of nature. Please join me in welcoming Natalie Walchova.
Thank you, James. I have to say, as a dropout of the Berkeley Physics Department, I never thought I'd make it onto this stage. More on that in a minute. First, congratulations to Berkeley's new bachelor's, master's, and PhDs in physics. And congratulations to your families, friends, and communities. You must be so, so proud. It's not an easy road to a physics degree, even in normal times. But you all haven't had a normal student experience. For the class of 2023, the pandemic disrupted much of your college career. Not long after you got here and were supposed to be social and make friends, you suddenly couldn't do that very easily. I also think about how you wouldn't have easily been able to gather in groups to study and do problem sets together, which is such a good way of learning physics. So there's no sugarcoating it. That's hard. So I want to applaud you extra much for overcoming those challenges and making it to this finish line. Of course, this is also, or more so, a starting line. As you look ahead to your future, whether you're planning to continue your academic career as a physicist, or go into finance, or software development, or engineering, or any other field, I want to offer you a perspective based on my observations. Knowledge is power, my grandpa always used to tell me. Well, I think knowledge of physics is a superpower. We tend to forget when we're in a bubble of people who've studied physics, as we are in this auditorium, just how unusual it is to understand the laws of nature. Galileo wrote that the universe is written in the language of mathematics, and its characters are triangles, circles, and other geometric figures, without which it is humanly impossible to understand a single word of it. Without these, one is wandering about in a dark labyrinth. You all understand the language of nature. You are not wandering about in a dark labyrinth. You have a headlamp on. That superpower will bring you many opportunities. The training you've had gives you the ability to reason clearly and logically about problems, to isolate the important details and ignore irrelevant ones, to model situations and make predictions based on equations. That all makes you really good at solving puzzles. And furthermore, it feels good to solve puzzles. Whether or not you end up being a research physicist and solving the puzzles of the universe, which if you do, call me, in all likelihood, you'll seek the kind of job that regularly provides that wonderful thrill of having solved a difficult puzzle. People will pay you a lot of money to solve difficult puzzles. My advice, or humble request really, is to always ask yourself, should you be solving this puzzle? Who will the solution benefit, and who might it harm? Is it a puzzle that the world needs solved? Take personal responsibility for the power that you possess. Consider the moral dimensions of your work. Think about what really matters to you and the impact that you want to have on the world. With your abilities, take care not to become a tool for achieving harmful ends. There's a famous historical example that illustrates both the power physicists possess and the moral complexity that can result from that power. That's the development of the atomic bomb. The physicists in the Manhattan Project thought they were in a race against German scientists who, had they developed the bomb first, would have won the war for the Nazis. So many of the American scientists felt morally obligated to try to invent the bomb first. Take Albert Einstein. He didn't work on the Manhattan Project directly because he couldn't get a security clearance, but his equation, E equals mc squared, was the basis of the idea that a small amount of matter could become a huge amount of energy. And in 1939, Einstein wrote a letter to President Roosevelt warning of possible German nuclear weapons research and advising that the United States should start a similar research program. After World War II, it became clear that German scientists had not been anywhere close to developing nuclear weapons. Einstein said if he had known this, he would not have written to Roosevelt. He had acted on too little information. After that, Einstein worked to control nuclear proliferation. Many of the Manhattan Project scientists did. And they lived their lives in anguish about the tragedies of Hiroshima and Nagasaki for the rest of their lives, many of them. It's a common dynamic, I think, in innovation. People convince themselves that someone else will do or make something if they or their team doesn't. So there's an attitude of, well, it might as well be us who does it. But the Manhattan Project scientists were wrong about that. Without their specific efforts, nuclear weapons would not have been used. That was not a clear-cut situation that they faced, so history doesn't condemn them, for the most part. But the bottom line is that brains and technical skills like yours can have enormous consequences. Don't let the pure intellectual thrill of solving puzzles subsume these kinds of moral and ethical considerations. Integrity and intentionality will make for a rewarding life. I fell in love with physics as a kid, as I'm sure many of you did, and I set out to become a physicist. I wanted to study at Berkeley, and indeed I had the honor and great fun of coming here for graduate school. But only after getting that close to my goal of becoming a physicist did I realize that it wasn't quite my calling. I didn't want to be a physicist. I just wanted to think and write about physics, to distill the meanings of new discoveries in physics, consider varying perspectives, and conceive an overall understanding. This all occurred to me over a single sleepless night during winter break after my first semester here. That night, I decided to quit my PhD program and instead pursue science journalism. And I called up the physics department the next morning and dropped out. I acted quickly because I knew they would need to find a replacement instructor for the discussion sections I was supposed to teach starting in a few days. Still feel bad about that. But I also felt sure of my decision. And indeed, it was the right one. I love what I do. So regarding what impact you want to have, another piece of advice I would humbly give you is to listen to your instincts and don't be afraid to quit or change course. So far, you've made excellent choices. You are where you need to be, where every parent dreams their child will be. But up to this point, the correct path has been more or less prescribed for you. Study hard, get a degree. Now the path to success gets more ambiguous, more individualized. Best of luck finding your path, and my most heartfelt congratulations to all of you for your tremendous achievement. Thank you.
Thank you, Natalie. Oh. So we now turn to the awards in physics. The Departmental Citation Award. The Physics Department Citation is awarded to a graduating student in recognition of distinguished undergraduate work. With so many outstanding students, it was a tough decision. The 2023 Physics Citation Award goes to James McGreevy. James, please come forward to the stage. And while you're walking up, I'm going to do my best to try and embarrass you. James began his research doing computational work with the Princeton Plasma Physics Laboratory. He received a Nuclear Science and Security Consortium Fellowship, where he researched neutron spectrum unfolding with neural networks, as well as Monte Carlo simulations of scintillator detector response functions. James spent a summer in Switzerland working under Joel Fagins as part of the Alpha collaboration at CERN on antimatter production and measurement. Most recently, James has been working on his honours thesis, Neutron Spectrum Unfolding with Neural Networks, which combines his computational work with the NSSC with the experimental data taken at the Lawrence Livermore National Lab. He plans to attend MIT in the fall, where he will be pursuing an interdisciplinary PhD in physics, statistics, and data science. Congratulations, James. Next, it is my pleasure to announce the winners of 3 Graduate Student Research Awards: the Lars Commons Memorial Award in Experimental Physics, the Jackson C. Koo Award in Condensed Matter Physics, and the Alex Zettel Graduate Student Award in Physics. Will the awardees please come to the stage? Now, this year's Lars E. Commons Award is presented to Paul Cabray. The Lars E. Commons Award was created in honor of the son of Professor Eugene and Mrs. Ulla Commons. This award pays tribute to the interests and accomplishments of Lars, who was an accomplished engineer with a deep interest in experimental physics. It is given annually to the most outstanding graduate student in experimental physics, and I am delighted to present the 2023 Lars E. Commons Award to Paul Cabray. We recognize Paul today for his outstanding work on the experimental research of amorphous topological insulators. His research advisor states that Paul's experimental work has tremendous intellectual impact, that over time I believe will prove to be paradigm shifting. That amorphous materials can host topological states, that case space is therefore not required for topological properties. There are real space analogues, and perhaps most remarkably, that localization effects in amorphous materials, rather than harming topological state creation, actually help by enhancing the effect of spin-orbit coupling. Paul's work is still the only experimental evidence for an amorphous topological material, which now has significant theoretical support. The Jackson C. Koo Award in Condensed Matter Physics is presented to Hongyang Lee. The Jackson C. Koo Award was created in 2009 to recognize outstanding advanced graduate students in condensed matter physics. Jackson Koo received his bachelor's and master's degrees with honors in electrical engineering, followed by his PhD in physics in 1969, under the guidance of Professor Erwin Hahn, all from UC Berkeley. He was a member of the Phi Beta Kappa and of the Honor Student Society of UC Berkeley. After graduating, he worked at Bell Labs and then Livermore National Laboratory. Hong Yang Lee has been selected for the Jackson C. Koo Award in recognition of his impact in the research of atomically thin van der Waals materials, one of the most exciting fields in condensed matter physics. Hong Yang's research accomplishments include obtaining results that reveal for the first time that the unexpected 3D moire reconstruction and strain redistribution play a dominant role in determining the lowest energy moire flat bands in tungsten selenide and tungsten sulfide heterostructures. I think I'm one of the few people in the room that can get that out in one mouthful. His work also allowed for direct visualization of the electron lattice of a generalized Wigner crystal state for the first time. And most recently, Hong Yang built a laser STM that combines laser excitation and cryogenic STM to probe optically excited states at atomic resolution, allowing him to directly image a new type of exciton state in a moire superlattice. Congratulations, Hong Yang. The Alex Zettel Graduate Student Award in Physics is presented to Yimu Bao. The Alex Zettel Graduate Student Award in Physics was established in 2022 with a gift from Erica and Herbert Zettel to be awarded to a graduate student in the Department of Physics with the most influential research accomplishments. Professor Alex Zettel received his BA from UC Berkeley in 1978 and his PhD from UCLA. In 1983. He has served as a faculty member of the physics department at UC Berkeley since 1983, where he became a leading expert in synthesis, characterization, and application of low-dimensional materials. Currently, he's Professor Emeritus of Physics at UC Berkeley, Senior Scientist at LBNL, and member of the Kavli Energy Nanosciences Institute at Berkeley. Now, Yimu Bao is awarded the inaugural Alex Zettel Graduate Student Award in Physics for his pioneering contributions to the research being done at the intersection of condensed matter physics and quantum information theory. In particular, Yimu led the development for a theoretical and conceptual framework to understand phase and phase transitions in quantum circuits with his measurements, and relating them to quantum information encoding properties of those circuits. Yimu has also been making a significant impact on our understanding of quantum information transitions in topological states subject to decoherence. Congratulations, Yimu. The next award is the Physics Student Service Award, which is given to recognize the importance of contribution. Oh, you may now leave the stage and... As you can see, we run a pretty tight ship around here. Okay, the next award, the Physics Student Service Award, is given to recognize the importance of contributions made by students to the physics community. We encourage students to work hard for themselves in coursework and research, but we also value the importance of seeing beyond personal gain to the greater good of our community. These awards are difficult to give because so many students donate time and energy to a variety of important activities. This year, we're recognizing 4 incredible students, 2 undergraduate students and 2 graduate students for outstanding service to the physics community. The awards go to Morgan Cole, Elena Grace Vasquez, Tessa Cook-Meyer, and Gwen Hanley. Morgan, Elena, Tessa, Gwen, please come forward to the stage. Morgan and Elena are receiving the Undergraduate Student Service Award in part for their leadership in teaching the Hidden Intersections decal, focusing on the past and present of systemic bias in STEM, specifically in the physical sciences. They used this experience and knowledge to lead a First Friday sessions for the entire physics community, focused on the concept that a student's sense of belonging in the department is a significant factor in their pursuing a physics degree. Both Elena and Morgan held leadership and committee positions in the department as well. Morgan as the Equity and Inclusion Chair for the Society of Physics Students and Service Course Committee member. Elena as co-president of the Society of Physics Students, DEI committee member, and one of the critical student leaders in the Discovery Arc program. Tessa and Gwen are receiving the Graduate Student Service Award in recognition for their multi-year contributions to the Respect as Part of Research peer-led training program, as well as their leadership and involvement in many other outreach programs that have helped make our science communities more accessible, inclusive, and welcoming. So I'd now like to present you with your awards. Now, each year we honour outstanding graduate student instructors in physics too, selected by undergraduates and the faculty for their excellent teaching. A couple of these OGSIs are here with us today. Will the awardees in attendance please stand as I read your names? Michael Arumayanagam, Jordan Edmonds, Thomas Ursabin, Adam Frim, Luc Leportier, William MacArthur, Sarah Moldovsky, Nathaniel Morrison, Aditya Prasad, Matthew Self, Jose Soria, Bethany Sutter, and C.K. Wolf. These graduate student instructors made extraordinary contribution to undergraduate education through the excellence of their teaching, their motivation, and their enthusiasm. Congratulations to you all. And now we turn to the main event, or the next part of the main event, to conferring the degrees themselves. We have set aside a front row of seats for all of the photographers. So when the time is right, please feel free to come down from your seats in the back and take photos. After taking the photos, please return immediately to your seats. We also have a professional photographer here today, Grad Images Photography, who will be mailing proofs to graduates directly. I'll now hand over to Dean Khan.
Thank you, James, and let me take this opportunity to offer my congratulations to such a wonderful array of students, and also to welcome their families and friends who have graced us with their presence today. As Elena pointed out earlier, today happens to be Mother's Day. It doesn't always fall, that commencement is on Mother's Day. But I hope for you moms in the audience that the pleasure of seeing your student receive a degree from one of the finest universities in the world will be a present that you'll remember for years to come. We have at Berkeley, in all modesty, one of the best physics departments in the world. But actually our students are our most prized resource. To our students, I know you've all been working very hard toward this day and over the last several years and those have been extraordinarily challenging years, as several of the previous speakers have already addressed. So the achievement that we're marking here today is all the greater for the challenges that you've faced. And while the pandemic has certainly presented immense difficulties for all of us, I also want to celebrate the strength, resilience, creativity, and tenacity that you, our wonderful students, have shown. Those are qualities you will carry forward with you into your careers as we emerge from the pandemic. You've also turned into amazing scientists. The best part of being on the faculty at Berkeley is engaging with your students. Nothing is more thrilling than sharing the spark of a new idea that emerges during a class discussion or working one-on-one with you on a particular research project. Whether or not you stay in the field of physics, I hope you will always be curious about the profound questions that we physicists ask and pursue research to try to answer. In the past few years, we've seen that science is paramount, and we're all better off if we understand how we got here and what we're made of. I too want to thank the faculty and staff of this department. These have been challenging years for them also, and I never cease to be impressed by the dedication of our staff and faculty to delivering on the core mission of our campus: teaching, research, and service to our communities. So thank you to you also. And finally, I want to offer a special thanks to our MC for this evening, our department chair, James Analidis. James has been an outstanding chair during a very challenging time. I've seen his work this year to bring the department back together, and it's been a real pleasure to work with him. Unfortunately, this will be James' last commencement as chair. He's chosen to take a well-deserved break and go back to teaching and research, so we'll miss him. And that introduces a challenge for me to find another chair, but we'll deal with that. Okay, now to the reason that we're all here. On behalf of the College of Letters and Science, I'm going to confer the degrees. First, the bachelor's degree in physics and engineering physics. This degree is conferred by the College of Letters and Science at Berkeley after a program of study usually requiring 4 years, which includes both general studies, broadly distributed as to field, and specialized studies at greater depth within a major subject. The aims of the bachelor program are twofold. First is to equip our candidates with the benefits of a liberal education in preparation for whatever leadership in society they may be called upon to exercise, and to equip them for further intellectual growth. Second is to prepare our candidates for further work in a major subject or some related field, either by formal academic study or as a graduate or by employment. Will the candidates for the Bachelor of Arts degree please rise? By virtue of the authority delegated to me by the Regents of the University of California, I hereby confer upon you the degree of Bachelor of Arts and of Bachelor of Science and all rights and privileges pertaining to that degree. You've taken the first step afforded by traditional academic processes in the development of a scholar, and I welcome you to the ranks of educated people. The candidates should now approach the stage, Roya Ferraris, our departmental manager, will call the names and hand out the scrolls. I guess, Holger.
Philip Robert Martin, double major, engineering physics and EECS. Go ahead. Divit Sharma. Mert Goldu. Yukan Liang. Kirill Nomov. Jinzi Wu. Ishita Malik. Sarah Ashley McKeon. Julia Marie Marks. Arundhati Osal. Shrihan Agarwal. Cameron Silver. Vishantak Shri Krishna. Elena Grace Vasquez. Rod Remy Sedig. Juliet Wright. Farima Dahaki. Bridget Meyer. Shreya Nagpal. Susanna Weber. Eric Yen. Raphael Bayer Way. James Sunseri. Miguel Ceja. V. Hong. Emma McGinnis. Samuel Joseph Paplanis. Michael May. John Brubaker. Mireles Carquena Barbosa. Vamshi Balanaga. Amaya Kunder. Antonio Sanchez Pierre. Larry Zhao. Gurpreet Singh. Rohit Sajas. Ranger Mo. Bin Han Hua. Nathaniel Rowe. Kyle Devereaux. Kevin Yee. Morgan Cole. Siddhant Ma. Jasmine Crawford. Aaron Torres. Miguel Montalvo. Brandon Lem. Daniel Schenk. Alexander Stov. Tomaso Figueiredo. Hailang Pan. Maxine Kraft. Yubin Hu. Zuri Wang. Idris Al-Khalidi. Hangbang Hua. Wan Fang. Wenhan Sun. Andrew Palmer. Alexander Wang. Max Fabian. Riley Paterlins. Daniel Tsui. Tristan Kimball. Josh Clover. River Hughes. Devin Lightfoot. Ryan Everly. Arman Badaran. Ronan Alam. Anton Ton. Richard Liu. Theodore Trask. Insop Paul Shin. Randy Wang. Ted Zhang. James McGreevy. Nicholas Kalem. Chan Min Kim. Coral Chen. Ananya Venkatraman. Sumed Rathi. Nathan Tausik. Samarth Yogesh Sheth. Angel Michael Yan. George Fritian. Thea Mollerstedt. Benjamin Sturworth. Cicely Lowe. Luke K.
We will now turn to the Master of Arts degrees. The degree of Master of Arts is awarded by the Graduate Division of the University of California after a program of study usually requiring 1 or 2 years of study beyond the bachelor's degree. In the master's program, the emphasis is upon coursework at an advanced level, often in preparation for teaching of the major subject at a college level, but sometimes in preparation for employment that requires a deeper knowledge of the specialty. Will the candidates for the degree of Master of Arts please rise? Do we have any? By virtue of the authority delegated to me by the Regents of the University of California, I hereby confer upon you the degree of Master of Arts and all rights and privileges pertaining to that degree. You have taken the second step afforded by traditional academic processes in the development of a scholar, and I welcome you to the ranks of those qualified to teach in your specialty at an advanced level. Candidates should now rise and approach the stage to receive their scrolls.
Yue Wang.
So we now turn to our PhD recipients. Recipients of the PhD wear the hood of the University of California. The design of the hood dates from medieval times when academic affairs were closely related to affairs of the church. The length of the hood and the blue velvet border signify the PhD and are common among universities. The blue and gold colors of the satin lining of the hood designate that the degree was conferred by the University of California. Research towards the PhD degree is highly individualized and carried out in close collaboration with a faculty research advisor. To symbolize this close bond, research advisors will hood their students who have earned the degree, and our faculty are seated to the right. They'll address the stage as their students are called up. The degree of Doctor of Philosophy is awarded by the Graduate Division of the University of California after a rigorous program of study and research, usually requiring at least 4 years of study beyond the bachelor's degree. In the program for the doctorate, the candidate must complete advanced coursework in the specialty, must pass 1 or more advanced examinations set by committees of the faculty, and must carry out extensive original research in the specialty in preparation for the writing and defense of a thesis. The doctoral program is highly individualistic and requires commitment to an extended effort of unpredictable outcome. The doctorate prepares those who attain it for a degree in college or university teaching and research or carrying out independent research at a comparable level in other settings. Will the candidates for the degree of Doctor of Philosophy please rise? By virtue of the authority delegated to me by the Regents of the University of California, I confer upon you the degree of Doctor of Philosophy and all rights and privileges pertaining to that degree. You have taken the final formal step afforded by traditional academic processes in the development of a scholar, and I welcome you to the ranks of those qualified for university teaching and research or comparable scholarly work in other settings. The candidates will now approach the stage and be hooded by their advisors.
Hadar Lazar. thesis title, Analyzing High Energy Transients, Spectral and Polarization Studies for Gamma Ray Bursts and Accreting Black Holes, hooded by John Tomsick and Stuart Bale. Hooding student, John Tomsick. Jacqueline Beechert, thesis title, Understanding Galactic AI-26 with the Compton Spectrometer and Imager, hooded by John Tomsick. Shannon Haley, thesis title, Studies of Frustration and Disorder via Electrical Manipulations, advisor James Analidis, hooding student James Analidis. Gregory Kanamoku Meyer, thesis title, Exploring the Limits of Classical Simulation from Computational Many-Body Dynamics to Quantum Advantage. Advisor Norman Yao, hooding student Norman Yao. Kathleen Hanley, thesis title, The Beginnings of Cold Ion Outflow at Mars, Supply and Energization near the Exobase. Advisor David Mitchell and Stuart Bale, hooding student David Mitchell. Tomohiro Soejima, thesis title, Numerical Study of Correlated Insulators of Magic Angle-Twisted Bilayer Graphene. Advisor, Michael Zalatel, hooding student, Michael Zalatel. Karthik Siva, thesis title, Multipartite Entanglement in Topological Phases. Advisor, Michael Zalatel, hooding student, Michael Zalatel. Julian Wolfe, thesis title, Coherent and Incoherent Quantum Feedback in a Cavity Atoms System. Advisor, Dan Stamper-Kern, hooding student, Dan Stamper-Kern. Zachary Pagel, thesis title, Towards a Next Generation Measurement of the Fine Structure Constant. Advisor, Holger Mueller, hooding student, Holger Mueller. Jeremy Axelrod, thesis title, A Laser Phase Plate for Transmission Electron Microscopy. Advisor, Holger Mueller, hooding student, Holger Mueller. Chitrang Mordia, thesis title, Bottom-Up and Top-Down Approaches to a Quantum Theory of Gravity. Advisor, Yasunori Nomura, hooding student, Yasunori Nomura. Elizabeth Dresselhaus, thesis title, Localization in Quantum and Classical Disordered Systems. Advisor, Joel Moore, hooding student, Joel Moore. Tessa Cookmeyer, thesis title, Transport in Quantum Materials, Lessons from Almost Exactly Solvable Models. Advisor Joel Moore, Hooding student Joel Moore. Yan Chi Wang, thesis title, Interplay of Symmetry Breaking and Topological Order. Advisor Joel Moore, Hooding student Joel Moore. Neil Glicken, thesis title, A Trapped Ion Quantum Planar Rotor. Advisor Hartmut Hafner, Hooding student Hartmut Hafner. Ryan Schaefer, thesis title, Efficient and Trusted Operation of Quantum Computers and Quantum Simulators. Advisor Hartmut Hafner, Hooding student Hartmut Hafner. Nicholas Huang, thesis title, Exploring the Kinematic and Thermal SC Effects with the South Pole Telescope. Advisor, William Holzapfel, Hooding student, William Holzapfel. Jessica Zebrowski, thesis title, Probing Inflation from the South Pole, a measurement of the B-mode polarization of the cosmic microwave background with SPT-3G. Advisor, William Holzapfel, Hooding student, William Holzapfel. Sam Guns, thesis title, Detection of Galactic and Extragalactic Millimeter Wavelength Transient Sources with SPT-3G. Advisor, William Holzapfel. Hooding student, William Holzapfel. Sean Beckman, thesis title, Advancements in Microwave Optics for Measuring the Cosmic Microwave Background. Advisor, Adrian Lee. Hooding student, Adrian Lee. Emma Deist, thesis title, Cavity Quantum Electrodynamics with Tweezer-Trapped Single Atoms. Advisor, Dan Stamper-Kern. Hooding student, Dan Stamper-Kern. Irina N.A., thesis title, Measurements of the Higgs boson decays to bottom and charm quarks in the WH production channel with the ATLAS experiment. Advisor, Heather Gray. Hooding student, Heather Gray. Marie Liu, thesis title, Multipartite Entanglement in Rabi-Driven Superconducting Qubits. Advisor, Irfan Siddiqui. Hooding student, Irfan Siddiqui. Yi Mu Bao, thesis title, Phases of Information Encoding in Many Bottom Quantum States. Advisor Ehud Altman, Hooding student Ehud Altman. Eric Aldepay, thesis title, Anisotropy and Disorder in Fractionalized Phases. Advisor Ehud Altman, Hooding student Ehud Altman. San Xuin Zhang, thesis title, Atomic Scale Visualization of Novel Two-Dimensional Correlated and Topological Electronic States. Advisor Michael Cromie, Hooding student Michael Cromie. Andrew Aikawa, thesis title, Investigating Diffusion Using Video Scanning, Tunneling Microscopy, and Deep Learning. Advisor, Michael Cromie. Hooding student, Michael Cromie. Franklin Leo, thesis title, Controlling and Imaging Molecular Motion at the Surface of a Gate-Tunable Graphene Device. Advisor, Michael Cromie. Hooding student, Michael Cromie. Jake Zhao, thesis title, Toward a Predictive Understanding of Developmental Decision-Making. Advisor, Hernan Garcia. Hooding student, James Analidis. Jin Wei Jian, thesis title, Topology and Electronic Properties of Low-Dimensional Carbon Materials. Advisor, Stephen Louie. Hooding student, Michael Cromie. Ryan Smith, thesis title, MIMP and WIMP, Searches with LZ and Characterization of Nuclear Recoils in Helium. Advisor, Dan McKinsey. Hooding student, Dan McKinsey. Bryce Coburn, thesis title, Applications of Holography and Quantum Information Dynamics, Chaos, Teleportation, and Metrology. Advisor, Norman Yao. Hooding student, Norman Yao. Thomas Schuster, thesis title, Many-Body Quantum Information Dynamics. Advisor, Norman Yao. Hooding student, Norman Yao. Gumpon Akarawarwang, thesis title, Exploring Interactions in Superconductors, Yushiba-Rusunov States, and Quantum Many-Body Effects. Advisor, Norman Yao. Hooding student, Norman Yao. Nicholas Dale. Thesis title, Tuning Correlations in Twisted Graphene Devices. Advisor, Alessandra Lanzara. Hooding student, James Analytis. Paul Corbet. Thesis title, Structural Disorder in Quantum Materials. Advisor, Francis Hellman. Hooding student, Francis Hellman. Unpil Beck. Thesis title, Exploring Electronic Structures with Near-Term Quantum Computers. Advisor, K. Birgitta Whaley and Joel Moore. Hooding student, Joel Moore. Peter Madigan. Thesis title, An Analysis of Muon Capture in a Novel Liquid Argon Time Projection Chamber. Advisor, Kambu Luck and Dan Dwyer. Hooding student, Dan Dwyer. Alwina Liu. Thesis title, Isolated Photon Jet Correlations in 5.02 TeV lead collisions with ALICE. Advisor, Barbara Yasek. Hooding student, Barbara Yasek. Dhruv Dixit. Thesis title, Nuclear Modification Factor in Isolated Photon Cross-Sections Measured in Proton-Proton and Proton lead at the square root of S equals 5.02 TeV with ALICE. Advisor, Barbara Yasek. Hooding student, Barbara Yasek. Alexander Avdoshkin. Thesis title, Dynamics and Responses of Critical Quantum Systems. Advisor, Joel Moore. Hooding student, Joel Moore. Nicholas Sherman. Thesis title, Transport and Spectral Functions in Low-Dimensional Quantum Spin Systems. Advisor, Joel Moore. Hooding student, Joel Moore. Adrian Bayer. Thesis title, Towards an Optimal Cosmological Detection of Neutrino Mass with Bayesian Inference. Advisor, Uros Seljak. Hooding student, Uros Seljak.
Well, that's just fabulous. We hope that all of you, baccalaureates, masters, and doctors of philosophy, will look back on your time here at Berkeley with pleasure and pride. You are part of a great tradition, and we are extremely proud of your accomplishments. So we are now at the end of this ceremony. Guests and families, please remain in your seats and allow the graduates and faculty to exit the auditorium first. Then please feel free to exit and reunite with your graduates outside. But before we begin leaving, with all the graduates, please rise and face your friends and family once more. I present to you the class of 2023. Fiat Lux and Go Bears!